Welcome to the second episode of this tutorial. Today, we're going to see how to install the platform and how to access all its microservices. Installing the platform itself is pretty simple. The only thing we need is having Docker installed in our operating system. You can find tons of videos on YouTube showing you how to install Docker, and it won't take you more than a few minutes. I'm doing this tutorial for absolute beginners, so it's worth giving you an idea of what Docker is and why we use it. Feel free to skip this chapter. In a nutshell, Docker is a tool designed to make it easier for developers to develop, ship, and run applications by using containers. Think of containers as a standardized packaging for microservices with all the requirements and configurations inside, such as libraries and other dependencies, and deploy it as a single package. By doing so, developers can rest easy knowing that this software will work properly on other systems besides the one they used for writing the code, thus preventing the headache of "it works on my machine." A container can run anywhere, on a laptop, in the cloud, on local servers, and even on edge devices. On the other hand, you'll hear the word Docker image. A Docker image backs up the application and the environment required by the application to run, and a container is a running instance of the image. Let me give you an example to better understand it. Images are the packing parts of Docker, analogous to source code or program. Containers are the execution part of Docker, analogous to a process. In the description below, you'll find a quick guide to Docker. I think it is a good place to start with. And the credits to someone on LinkedIn. I don't know him exactly. Hopefully, this was enough to have a clear picture of why Docker. Now, let's install the platform. Go to their GitHub repository. You'll find the link below. First of all, let's download this repository. I have already done that. Then unzip it to your preferred location. Next, go to the standalone directory and open a terminal. After that, let's download the images used in the platform. As I said earlier, these images are like the programs we install in our operating system. We only need to do this once. For the first time, it will take some time to download all these images, depending on your internet connection. To do this, just type Docker Compose up in the terminal. As you noticed, I'm using Docker Compose instead of Docker CLI, and the difference between the two is that Docker CLI used to manage individual containers, whereas Docker Compose used to manage multi-containers applications, which is the case with Libre. And for that, we use a YAML configuration file, in which we define everything needed for the containers to work together. After pulling all the images, the platform will be launched automatically. But it does not work that way. You must see some errors, and you may face this one. Let me explain why. In this config file, we see that some containers depend on others. For example, the container of Libre UI won't run if the containers InfluxDB, MQTT 0, and or alpha did not run in healthy condition on the time set or on time set in health check conditions. Just give the containers some time and then do Docker Compose up. So at the end of this video, I'll show you a better workaround to prevent it. If you see this, congrats, you have now the platform up and running. For now, let's access these containers. For InfluxDB, its port is 8086, the username and the password in the YAML file. Go to the browser and type in localhost :8086 and voila, you're in. Let's say another one. For Grafana, the port is 3000 and the same password as the one for InfluxDB. We'll change it later. Let's go to Libre Admin. The port is the default for localhost. But before that, we need to sign up for an account in Auth0. I'll tell you why later. Now you're in, but nothing is showing here. And the reason why, because you don't have permission. Go to localhost users and give yourself the admin role. Go back to localhost and you're good now. Don't worry about the inactive container. Its role is to upload the schema and add this getting started configuration. Let's say the low-code platform of Appsmith. The port is 3080, and we'll leave this one at the end of this tutorial. Let's access the Libre Gateway endpoint at localhost :4000/GraphQL using the GraphQL Playground IDE. We'll be using this one a lot. I'm using MQTT Explorer to access the MQTT broker. It is open source and the best MQTT client for me. I'll leave you the link below to download it. Let's create a new connection to the broker. The URL is localhost. Username and password are in the Docker Compose file, and you can change them if you want. Let's add some topics, and the one used for the getting started example is pachymo /$ or hash. It means that we want to subscribe to all the topics under pachymo. Speaking of subscribing, don't forget to subscribe for upcoming videos to get notified. As mentioned before, let's change the password for both InfluxDB and Grafana to get everything ready for the next episode. To prevent losing data, we have to persist it to the host by just uncomment these lines and be aware of the indentation. Let me show you the workaround I told you about. To run the platform properly, it is better to run these containers first: InfluxDB, MQTT, Alpha, and 0, as almost all the other containers in the platform depend on them. You can use Docker Compose -d app to run it in the background. We check if these containers run in a healthy condition by Docker Compose PS. If all of these 4 containers are healthy, then hitting Docker Compose app, everything will run smoothly. To reconnect to InfluxDB or Grafana, use the newly created password. For Grafana, it is the main or the admin password. There is another option to log in just by clicking on Sign in with Auth0, which is the same user you logged in with to Libre Admin. Here is a bonus for Windows users. To work comfortably with Docker, especially if you don't have enough resources in your computer, add this file in your user directory and add these lines. This will limit the use of memory and CPUs by WS, which is Windows Subsystem for Linux. Hopefully you guys enjoyed it. See you in the next episode. Thank you for watching.